Welcome. All right, let's dive straight in.
Let's do it.
Today we're tackling helicopter flight, really getting into the essentials.
The nuts and bolts, basically. How pilots actually fly these complex machines.
Exactly. We're drawing on some really detailed material covering the basic maneuvers.
And our goal here really is to give you a shortcut to understanding the core techniques, what pilots are actually doing up there.
Right. So whether you're prepping for something or just, curious about helicopters, this should give you the fundamentals.
Okay, first thing to get out of the way. Performance varies a lot.
Yeah, the source material makes that super clear. Wind, temperature, humidity.
Weight, even the specific equipment on board. It all impacts how the helicopter performs.
So you can't just memorize one power setting and call it a day.
Definitely not. But the techniques we're talking about, they're pretty universal, especially for the common single-rotor counterclockwise systems.
Though you'll mention differences, like for clockwise rotors needing opposite pedals sometimes.
Exactly. And because it varies so much, we won't be quoting exact nose attitudes or power settings much. It's more about how you do it, the technique.
Which feels more useful anyway. Developing that feel, understanding the why.
That's it. And it all comes down to the four fundamentals.
The absolute bedrock. Straight and level, turns, climbs, and descents.
Every single controlled maneuver builds on those four. Simple as that.
And the source says mastering these isn't just mechanical, it's about developing that feel, right? Instinctive control.
Precisely. If students struggle later with complex stuff, it usually traces back to not quite having these fundamentals down pat.
Makes sense. So what about general guidelines for maneuvering? Any key takeaways?
A big one is cyclic control. The source stresses, only move it as fast as you can, keep everything else in check. Trim, torque, rotor speed.
So don't get ahead of the aircraft, basically. Or yourself.
Yeah. If things feel like they're happening too fast, you probably need to reduce the intensity of the maneuver. Cyclic is sensitive.
And anticipation is crucial. You mentioned performance variation.
You have to anticipate how changes will affect the aircraft based on conditions. High and hot. You'll need more power. Things will feel different.
The source even lists some expected changes, like left turns increasing torque.
Generally, yes, in counterclockwise systems. You'll need more left pedal. Right turns, torque might decrease slightly, so less pedal.
And cyclic movements affect torque too. Aft cyclic decreases it, forward increases.
Can do, yeah. Especially forward cyclic after pulling back. It's all interconnected, like you said.
What else? Always have an out.
Always. And know where the wind is. Always. Always know the wind.
Non-negotiable in a helicopter, I imagine.
Absolutely. And don't neglect the basics like engine monitoring. Carb ice can ruin your day.
Crew coordination too, if applicable. Everyone on the same page.
Definitely. And steep turns, they highlight power demands. The
The
nose drops, you need power, or you trade airspeed for altitude.
source mentioned a 60-degree turn needing potentially double the power.
It can, yeah. A 2G turn requires a 100% increase in total rotor thrust just to maintain altitude and airspeed. Huge demand. Failing to anticipate that low down is bad news.
And landings, especially to a hover, are high-power events.
Often the highest power you'll use. Finally, remember, cyclic position relative to the horizon. That dictates your travel and attitude, your main positioning tool.
Okay, let's get into specifics. Hovering seems like the place to start. It's so unique to helicopters.
It really is. The vertical takeoff to a hover, straight up, maybe 2 or 3 feet skid height, constant heading, perfectly still over a spot. It takes huge concentration.
How's it done? Smoothly on the collective.
Very smoothly. Start collective down, cyclic neutral or slightly into wind, gently raise the collective. Feel it get light.
And pedals. Torque comes in as power increases.
Right, so as you lift, you need pedal, usually left pedal for counterclockwise rotors to keep the nose straight.
Yeah.
Use cyclic just to ensure you're going straight up.
The source suggests doing that initial liftoff slowly.
Yeah, it's a built-in check. Lets you feel the helicopter's response. Check the CG. If it feels weird, wants to tilt, you just lower the collective and sort it out. Don't fight it into the air.
Smart. Once you're in the hover, how do the controls work?
Okay, this is key. Pedals control heading and turn rate. Collective controls altitude up, down. Cyclic controls position over the ground, forward, back, sideways.
And staying still, small inputs.
Tiny, constant adjustments. And remember, a hover is rarely perfectly level, usually a bit left side low because of the tail rotor thrust. Check your power, note what it takes.
This sounds like where over-controlling happens easily.
Oh, absolutely. You drift right, you push left cyclic, now you sink slightly, so you raise collective. That increases torque, so you need more left pedal, maybe more throttle for RPM. Say, cascade.
One correction creates the need for 3 more.
Exactly. Proficiency means making tiny, smooth pressure changes, almost before you consciously notice the drift. That's the feel again.
Stationary hovering, then, is just refining that, using peripheral vision.
Yeah, look slightly out, not straight down. Catch deviations early. Make the correction, and crucially, neutralize the control input before the helicopter actually stops moving to account for lag.
Anticipating again. Common mistakes here. Being tense.
Tense is bad. Slow reactions, over-controlling. Hovering too high gets you into the dangerous part of the height velocity curve, or too low, risking touchdown or dynamic rollover.
Let's talk hovering turns, rotating while staying over the spot.
Right. Initiate with pedal pressure. Left turn needs more power, right turn needs less for counterclockwise rotors.
Because left pedal increases tail rotor thrust and engine load.
Exactly. You use cyclic to stay perfectly over your spot, usually a bit of cyclic into the wind.
And wind makes a big difference here.
Huge. Turning crosswind, the wind hits the tail, you need more pedal to fight that weather veining, then turning downwind.
The wind pushes the tail around faster.
Right, so to keep a constant turn rate downwind, you actually need opposite pedal pressure to slow it down, plus aft cyclic to stay over the spot. It feels weird, but it works.
And high winds can limit tail rotor effectiveness, especially in right turns.
Can be an issue. The source suggests checking a left turn first if you're unsure. If you can handle the crosswind, the right turn should be okay.
Hovering forward, sideward, rearward, same control principles, just moving slowly.
Basically, yes. Cyclic for direction and speed keep it slow, like a walk. Pedals for heading, collective for height. Sideward needs extra care for tail clearance. Rearward needs thorough clearing beforehand.
Okay, moving on. Normal takeoffs. Transitioning to forward flight safely.
Key goal. Avoid that height velocity diagram, dead man's curve. From a hover, you do checks, clear the area, then ease cyclic forward smoothly.
Increase collective to stop sinking.
Coordinate throttle for RPM, pedals for heading. As you accelerate, you'll hit effective translational lift, ETL.
That's where the rotor gets more efficient.
Yes, feels like a little boost. The helicopter wants to climb, nose pitches up. You need forward cyclic to counter that, keep accelerating, adjust collective for climb power, staying out of the HV curve.
And start crabbing into the wind for track.
Right. Taking off from the surface is similar, but starts with collective low, gently lifting off, then applying forward cyclic. Uses less power initially.
What about crosswinds during takeoff? Close to the ground. The source mentions a slip.
Yeah, below about 50 or 100 feet. You use cyclic into the wind to stop drift, but keep the nose pointed down your takeoff path using pedals. So you're flying slightly sideways relative to the fuselage.
But above that altitude, you transition to a crab.
Correct. You turn the nose slightly into the wind to maintain your ground track.
Let's cover turns next. The source was really clear. No pedals to start the turn.
Absolutely critical. Entry is sideward cyclic pressure only. Bank the rotor disc. Pedals are just for trim, keep that ball or string centered.
The amount of cyclic pressure sets the roll rate. How long you hold it sets the bank angle.
And once banked, ease cyclic toward neutral to hold it. Coordinate collective throttle for altitude or PM, pedals for trim as torque changes. May need a bit of forward cyclic to hold airspeed in steeper banks.
Rollout is opposite cyclic, starting before the heading.
Gotta anticipate. Now, slips and skids. A slip.
Sliding toward the center of the turn. Not enough pedal into the turn.
Or too much opposite pedal. Rate of turn too slow for the bank. A skid.
Sliding away from the center. Too much pedal into the turn. Forcing it. Rate of turn too fast for the bank.
Keep that ball centered. Main errors are using pedals wrong, not staying coordinated or trimmed.
Okay, climbs and descents. Building on straight and level. To climb.
Increase collective and throttle. Adjust pedals for trim. And crucially, apply slight aft cyclic.
Why aft cyclic?
Helps direct that increased power vector upwards into lift, maintaining your climb airspeed. Remember, attitude shows acceleration, not just climb angle.
Leveling off from a climb, lead the altitude.
By about 10% of your climb rate, so 50 feet for 500 ppm climb. Forward cyclic for level attitude, reduce collective to cruise power, adjust trim.
Descent is the reverse. Lower collective, adjust throttle pedals, use cyclic to set descending attitude and airspeed.
And level off, similarly, leading by 10%, increasing collective back to cruise power, adjusting everything for level flight. Big error in both. Forgetting pedal changes with power changes.
Ground reference maneuvers, these sound like pure training exercises.
Mostly, yes. Rectangular course S-turns. They teach you to divide attention and, critically, manage wind drift by constantly adjusting bank and crab angle.
Like in S-turns, downwind means faster ground speed, so steeper bank needed.
Exactly. Headwind, slower ground speed, shallower bank. You're constantly adjusting based on your ground track relative to the reference line or point, and always crabbing into the wind.
Traffic patterns. Helicopters do it differently.
Generally, yeah. To stay clear of faster fixed-wing traffic, we often fly lower, maybe 500,000 feet, and often use opposite turn directions. Right turns are common since the pilot's often on the right.
Depends on the airport procedures, though.
Always check local procedures. At towered airports, just tell them your intentions. They'll usually keep you separate.
Okay, approaches. Getting down safely. Normal approach to a hover.
Aiming for a specific spot. On final, maybe 300 feet, good airspeed. Lower collective to start down the desired angle. Nose pitches down, so use aft cyclic to hold the attitude for your approach airspeed. Pedals for trim.
Here's that interesting control distinction again. Collective controls the angle.
And cyclic controls the rate of closure, how fast you're approaching the spot. Think brisk walk, ground speed.
And you lose ETL on the way down.
Around 25 knots or so. Requires more collective to maintain the angle. Nose might rise, so use forward cyclic to keep that closure rate steady.
Then arriving at hover height?
Smooth but definite increase in collective to arrest the descent. Aft cyclic to stop forward movement. Pedals for heading. All ideally happening simultaneously. High power demand here.
Common errors, not arriving at zero speed and hover height together. Crosswind issues.
Yes, and forgetting to transition from a crab to a slip below 5,100 feet in a crosswind is a big one. Need cyclic into wind, pedals to align the fuselage for landing.
Normal approach to the surface, just continue down without the hover.
Right, good for dust snow. Aim for level touchdown, zero ground speed, minimal descent rate. Cushion with collective. Errors, landing with drift or forward speed. Bad alignment risks dynamic rollover.
Finally, the go-around, aborting the landing.
Crucial safety maneuver. If anything feels wrong, traffic, position, instability, make the call early, positively, without hesitation.
What's the immediate action?
Power. You're likely low on power, first thing. Smoothly apply takeoff power with collective. Coordinate throttle for RPM, pedals for heading, establish a climb attitude, get climb speed, and set up for another try.
We've covered a massive amount of ground, or rather air, from hovering to flying patterns.
And the constant theme is that coordination.
Yes.
Cyclic, collective, throttle, pedals all working together all the time. It's not pushing buttons.
It's that continuous feel, anticipating, reacting. Those fundamentals are everything when things get tricky.
Absolutely. A sudden dust, an engine issue, needing that go-around your mastery of the basics is what gets you through safely.
It really emphasizes how active helicopter piloting is. You are constantly flying the machine moment by moment. It's a unique relationship between pilot and aircraft.
It really is. And there's always more depth to understand about why it all works the way it does.
Absolutely. Well, thanks for walking us through these core maneuvers.
My pleasure.